Alright, we will start with the next question. An entire system is characterized by the system function given h of z. Under what conditions the system will obey causality and stability? That is a 4 marks question, okay? That is a 4 marks question. This is first part. And also determine the impulse response of the system such that the system is causal, okay? Impulse response such that system is causal and impulse response such that system is stable. So we have two parts for this question. Let's solve the first one. So we are given h of z equal to 3 minus 4 z inverse divided by 1 minus 3.5 z inverse plus 1.5 z inverse 2. So let's try to factorize the denominator, keeping numerator as such. So how can you factorize denominator? We have to take two numbers whose sum is minus 3.5 and product is 1.5. That turns out to be 1 minus 3 z inverse into 1 minus zero point 0.5 z inverse, right? Because minus 3 minus zero point 0.5 is minus 3.5, correct? And minus 3 into minus zero point 0.5 is plus 1.5. You're correct. So the factorization is okay. Now we would use the traditional method of making it a partial fraction. So a by 1 minus 3 z inverse plus b by 1 minus zero point 0.5 z inverse. Okay, so let's find out the values of a and b. So value of a will be a equal to, as you know, you multiply the transfer function with the denominator of a. That is, you multiply 1 minus 3 z inverse with this whole transfer function, and that will give you 3 minus 4 z inverse divided by 1 minus 3 z inverse will get cancelled. So 1 minus zero point 0.5 z inverse, provided z inverse equal to, what is z inverse? Z inverse should be that value which makes the denominator of a 0. Okay, so z inverse will be obviously 1 by 3. So z inverse equal to 1 by 3. So that is equal to 3 minus 4 into, put z inverse as 1 by 3, divide by 1 minus zero point 0.5 into 1 by 3. That is equal to 3 minus, 5 divided by 3 divided by 1 minus 1 by 6 is 5 by 6. That is equal to 2. Okay, so we got the value of a as 2. Similarly, what is b? B is equal to 3 minus 4 z inverse divided by 1 minus 3 inverse, provided z inverse is equal to, what should be the value of z inverse? It should be equal to 2. Okay, z inverse equal to 2. 2 will putting 2 here will make this denominator 0. Okay, so that is equal to 3 minus 2 divided by 1 minus 6. I'm sorry, this is okay, this is 3 minus 4 into is 8. Okay, 3 minus 8 divided by 1 minus 6, this is minus 5 divided by minus 5 equal to 1. So we got a as 2 and b as 1. Now we can replace a and b with the given values. So that turns out to be h of z is equal to, a was 2, 2 by 1 minus 3 z inverse, plus b was 1, 1 by 1 minus zero point 0.5 z inverse. This is the expression for h of z. And I can always rewrite this equation as taking LCM of z inverse. So considering z inverse as 1 by z and taking LCM, this is 2z by 1 minus, um, 2z divided by z minus 3 plus z by z minus zero point 0.5. Okay, we can write in either way of this, right? Now let us see the first part of the question again. Under what conditions the system will obey causality and then stability? So um, let us find or let us draw the pole zero plot of this h of z. Okay, so this is a z plane, and this is the pole z equal to 0.5. We have to know that from this denominator z equal to 0.5 is a pole, from this denominator, z equal to 3 is also pole. So these are the poles of this transfer function h of z. So I can write this as this is equal to 0.5 and this is equal to 3. This is plane. Okay. Now to be causal, to obey causality, what should be the condition of ROC? To be causal, ROC should be such that it should be outer to the outermost plane. So I can mark this area. Okay, outermost pole is 3, so ROC will be outer to the outermost pole. So this is the ROC. And how can you represent this ROC? You can represent ROCR as for causality. For causality, ROC is such that mod z greater than 3. So this is mod z greater than 3. Okay, and that's the answer to the first question. And what is the condition for stability? For stability, we know. For stability, we know the ROC should contain unit circle. So I can draw the unit circle also. I can draw the unit circle somewhere here. Okay, so assume this is the unit circle. So the ROC should contain the unit circle. I can mark the ROC with some another color. Okay, so ROC should be such that it should be between two poles. So including unit circle means this is the only possibility. So this shaded portion is the only way to give the ROC if the system is stable, so that it contains the unit circle. Okay, so I can write it as this is the ROC for stability, which is given by, how can you represent it? 1 by 2 less than mod z less than 3. Okay, so for stability I can rewrite it as ROC is 1 by 2 less than mod z less than 3. Okay, so these are the answers to part 1 of the question. And now we will check the answer to the second part. Determine the impulse response. We have to find out the impulse response. We are given h of z and you have to find out h of n such that the system is causal and the system is stable. Okay, so let's find out or let's recall what was h of z. H of z from the previous case, we know it was h of z is equal to 2z divided by, it was z minus 3, I remember, plus, and that was z by z minus 0.5. Okay, right. So okay, yeah, now we have to find out h of n for the system is stable. Okay, first condition, system is stable. So this is the pole 0 plot of this h of z. We have a pole at 1 by 2 and a pole at 3, and this is the unit circle. Okay, and from the previous session, for stability we are dealing with the stability h of n when the system is stable. So for a stable system, we have already seen that the region of convergence will be including the unit circle. So the only possibility is mod z is, or yeah, mod z or region of convergence is between 1 by 2 and 3. We can write it as 1 by 2 less than mod z less than 3. We have seen it in this previous session. So for this, so this session corresponds to the circular disk between half and 3. Okay, so for getting that, the only possibility is having a region of convergence with respect to the pole 1 by 2. With respect to the pole 1 by 2, the ROC will be like this. Okay, I will come to it, the detail later. So for with respect to the pole half, the ROC should be outwards, something like this. Okay, and you know, that's for the pole half, and for the pole 3, as with respect to the pole 3, the ROC should be something like this. Inwards, right? So with respect to pole 3, the ROC should be like this. Then only the intersection of these two ROCs give this circular disk part, that is half less than mod z less than 3. Okay, so I repeat, what we have done is, with respect to pole half, the ROC was, I can write, with respect to pole half, ROC was like mod z greater than half. Okay, with respect to pole 3, ROC was like mod z less than 3. So clearly, with respect to pole half, we have a right-sided signal in time domain while we do the inverse transform, and with respect to pole 3, the ROC indicates that it is a left-sided signal. Okay, right. So we can write that h of n is equal to, with respect to, finding the inverse transform of this term, with respect to pole 3, it is a left-sided signal. Okay, so minus 2 into, there's a 2 here, and inverse transform of z by z minus 3 is minus 3 raised to n u of minus n minus 1 plus, and now finding the inverse transform of this term, the pole is 0.5, so for pole 0.5 this is the right side signal, so this 0.5 to the power n u of n. So this is the impulse response when the system is stable. Okay, the first subpart is over, and now the second question, or the other question is the system, or the h of n when the system is causal. For causality, we know the ROC should be this portion, right? ROC should be such that it is outer to the outermost pole. Here the outermost pole is 3, so this is the ROC. For that, both the signals corresponding to both the terms should be right-sided. Okay, so we can write h of n is equal to, inverse transform corresponding to this term is right-sided, so 2 into 3 raised to n u of n, plus inverse transform corresponding to this term is also right-sided, so that is 0.5 raised to n u of n. So this is the answer for h of n when the system is causal. And jumping on to the next question, the frequency response of a 3-point moving average system is given as h of e raised to j omega is equal to 1 by 4 into 1 plus cos omega e raised to minus j omega. Determine the difference equation representation of the system. This question is very simple. So h of e raised to j omega is equal to, expanding the bracket, I can write 1 by 4 e raised to minus j omega plus 1 by 4 e raised to minus j omega into cos omega. Okay, and this is right, this is equal to 1 by 4 e raised to minus j omega plus, in this term the Euler equation becomes handy for replacing cos omega with exponentials, so 1 by 4 e raised to minus j omega as such, but cos omega can be written as 1 by 2 e raised to j omega plus 1 by 2 e raised to minus j omega. This is our usual Euler's theorem. Now expanding the bracket again, 1 by 4 e raised to minus j omega plus multiplying 1 by 4 e raised to minus j omega into the bracket, we will get 1 by 8 into 1, because e raised to minus j omega into e raised to j omega will become 1, plus again 1 by 8 into e raised to minus j omega into e raised to minus j omega will give you e raised to minus j2 omega. Okay, so this is h of e raised to j omega, and you know this h of e raised to j omega is given as the frequency response, which is nothing but the ratio of output response divided by input response. So I can write it as y of e raised to j omega output response divided by input response is equal to 1 by 8 plus, I'm just rearranging, 1 by 8 plus 1 by 4 e raised to minus j omega plus 1 by 8 e raised to minus j2 omega. Now cross multiplying, y of e raised to j omega is equal to 1 by 8 x of e raised to j omega plus 1 by 4 x of e raised to j omega into e raised to minus j omega plus 1 by 8 x of e raised to j omega into e raised to minus j to omega. Now you need to find the inverse Fourier transform. Okay, inverse Fourier inverse DTFT on both sides. You will get the inverse of y of e raised to omega is equal to y of n. So y of n is equal to inverse of 1 by 8 x of e raised to j omega is nothing but 1 by 8 x of n, 1 by 8 x of n plus the inverse of next term is, what is the inverse of e raised to minus j omega into x of e raised to j omega? This is according to the time shift property of Fourier transform. So its inverse will be 1 by 4 x of n minus 1. Okay, plus for the final term, this is e raised to j minus j 2 omega. So time shift will be 2 units. So 1 by 8 x of n minus 2. So this is the difference equation representation. That's the final answer. Well, we will get on the next question. Determine the response of the system with impulse response h of n equal to 0.5 raised to n of n to the input signal x of n equal to 10 minus sine pi by 2 n. So we have to find the y of n. The impulse response and input are given. So output y of n should be found out. I think this question is a slightly tricky question because of the existence of sine term in this x of n. But never mind, we will crack it off. So it was given that h of n is equal to 0.5 raised to n u of n. Okay, therefore we know that the DTFT of h of n is given by h of e raised to j omega. That will be equal to 1 by 1 minus 0.5 e raised to minus j omega. We know from the standard results, right? And now we have to find out x of e raised to j omega also. But given x of n is equal to 10 minus sine pi by 2n. And how will you find out x of e raised to j omega? This is, we cannot directly find out x of e raised to j omega because of the existence of sine term. So this is a case where we can use the Euler's theorem in handy. So using Euler's theorem, I am writing sine pi by 2n as 1 by 2j e raised to j pi by 2n minus 1 by 2j e raised to minus j pi by 2n. Okay, so this is the expression for x of n. Now we can find out x of e raised to j omega. Therefore, x of e raised to j omega equal to, so we have to find out the DTFT for each term. And how will you find out the DTFT of 10? You know that, writing here, Fourier transform of 1 is equal to 2 pi del of omega. Okay, therefore we can write Fourier transform of 10 will be equal to 10 into 2 pi del of omega. So 10 into 2 pi del of omega minus, now what is the Fourier transform of 1 by 2j e raised to j pi by 2n? Again we can use this relation and the frequency shift property, because what's the Fourier transform of 1 into e raised to j theta n? That will be equal to 2 pi del of omega minus theta, right? This is multiplying the time domain with exponential. That means frequency is shifted. This is frequency shift property. Okay, similarly I can write Fourier transform of e raised to minus j theta n. 1 into e raised to minus j theta n will be equal to 2 pi del of omega plus theta. Okay, with the help of this relation, the Fourier transform the second term will be 1 by 2j into 2 pi del of omega minus pi by 2, and the next term is, you have minus and minus, so plus again 1 by 2j into 2 pi del of omega plus pi by 2. Okay, so this is the expression for the Fourier transform of the input. Now, as per the traditional methods, we have h of e raised to j omega, right? H of e raised to j omega here and x of e raised to j omega here. So the response, or y of e raised to j omega, using a convolution property of DTFT, we can write it as x of e raised to j omega into h of e raised to j omega. That means we have to multiply this term with the whole of this expression. That implies y of e raised to j omega is equal to, here it is 20 pi del of omega by 1 minus 0.5 e raised to minus j omega is the first term. Okay, and for the second term, we can cancel these 2 and 2. So minus pi by j into del of omega minus pi by 2 divided by 1 minus 0.5 e raised to minus j omega. And last term is, again we can cancel 2. So pi by j into del of omega plus pi by 2 divided by 1 minus 0.5 e raised to minus j omega. Okay. So now we have got y of e raised to j omega. Now to find y of n, the response, you need to find out the inverse DTFT, IDTFT. But in traditional problems, what we do is we take the inverse by making this RHS into partial fraction expansion form and directly finding out the IDTFT. But this is why I said that initially it is a tricky question, because you cannot find out the partial fraction expansion for this expression because of the presence of del of omega term. Okay, so now what we do is we go to scratch, right? Therefore, from the equation of DTFT, y of n is equal to, it is 1 by 2 pi integral over 0 to 2 pi y of e raised to j omega into e raised to j omega n d omega. This is the expression for time domain from the DTFT definition. We had some analysis equation and synthesis equation for DTFT. So this is it. Okay. Now we find out y of n using this relation. Okay. Therefore, y of n is equal to 1 by 2 pi into integral 0 to 2 pi. The first term is 20 pi del of omega by 1 minus 0.5 e raised to minus j omega into e raised to j omega n d omega minus 1 by 2 pi integral over 0 to 2 pi pi by j into del of omega minus pi by 2 by 1 minus 0.5 e raised to minus j omega into e raised to j omega n d omega plus last term is again integral 1 by 2 pi integral 0 to 2 pi by j into del of omega plus pi by 2 by 1 minus 0.5 e raised to minus j omega into e raised to j omega n d omega. Okay, so I think you are clear up to this. Now how to find out this integral? This is equal to, since there is an impulse function in all the terms of under this integral, we can use the property of impulse, which is nothing but integral minus infinity to plus infinity x of t minus t0 into del of t dt will be equal to x of I'm so sorry. Integral, the property is integral x of t into del of t minus t0 dt will be equal to what will be the answer? It will be the other function other than impulse function at t0, right? The impulse is present at t0, so the function reduces to x of t0, a scalar at t0, right? So using this property of impulse, we call it shifting property. So we can write this as the first term as, we can cancel out pi to cancel to 10, so 10 into, what is the value under the integral? Here what we have is del of omega, right? We have del of omega. It exists at omega equal to 0. So all the other function will exist at omega equal to 0. So put omega equal to 0 wherever you find this function, you find omega in this function. So I can write it as 10 into e raised to j0 divided by 1 minus 0.5 e raised to minus j0. That's all about the first term. Okay, minus in the second term we can cancel pi, so 1 by 2j into in the second term we have del of omega minus pi by 2. So this function, in this function impulse exists at omega equal to pi by 2. So what we have to do is the value of the integral becomes this function at omega equal to pi by 2, right? This function reduces to a scalar at omega equal to pi by 2. So I can write it as 1 by 2j into e raised to j pi by 2n divided by 1 minus 0.5 e raised to minus j pi by 2n. Instead of omega, I gave pi by 2. So similarly, the last term also pretty similar, plus 1 by 2j into, here the function exists at omega equal to, del of impulse function exists at omega equal to minus pi by 2. So you give the entire other function at omega equal to minus pi by 2. Pretty simple. So 1 by 2j into e raised to minus j pi by 2n, you put omega equal to minus pi by 2, divide by 1 minus 0.5 e raised to plus, we have a minus here, so minus minus plus j pi by 2 n. Okay, so this is this can be slightly further simplified as, therefore y of n is equal to e raised to j0 is 1, e raised to j0 is 1, so 10 by 1 minus 0.5 is, it's 10 by 1 minus 0.5, it is 10 to 20, right? Okay, so this is 20 minus, we cannot do much simplifications here, so we can write it as 1 by 2j e raised to j pi by 2n by 1 minus 0.5 e raised to minus j pi by 2n plus 1 by 2j e raised to minus j pi by 2n by 1 minus 0.5 e raised to plus j pi by 2n. So this will be the final answer to the question. And now we head on to the last question in this book. Find the Z transform and specify the ROC for two signals. First question is x of n is equal to u of n minus 2 convolution convolved with 2 by 3 to the power n u of n. Okay, so you have to find the Z transform and specify the ROC. So x of z is equal to, how to find out the Z transform of these RHS? This is, you have a convolution in time domain, so in Z transform domain it becomes multiplication. So we have the Z transform of u of n minus 2 into Z transform of 2 by 3 to the power n u of n. This is pretty simple because Z transform of u of n is z by z minus 2, but there is a time shift of 2 units, so z raised to minus 2 into z by z minus 2 into, what is the Z transform of this term? This is a direct one. We know the relation z by z minus 2 by 3. Okay, therefore x of z is equal to, we have z into z raised to minus 2, so 1
by z minus 2 into z minus 2 by 3. So this is the z transform. And what is the ROC? ROC is actually there are two poles, right? Two poles corresponding to these two factors. So at poles at z equal to 2 and z equal to 2 by 3. Okay, so these two signals are right-sided signals, right? U of n minus 2 is right-sided. Similarly, 2 by 2 to the power n u of n is also right-sided. So the ROC of both the signals are right-sided. So the effective ROC of the total term x of z will be the intersection of ROC at z equal to 2 and intersection of ROC at z equal to 2 by 3. Both are right-sided, so the common factor will be ROC at mod z greater than 2. Okay, this is I can explain once again if you are a bit confused, because we have two poles. One is at 2 by 3, so this is the circle corresponding to that pole. The other is 2. Other pole is 2, so this is the circle corresponding to, assume that this is a circle corresponding to 2. So both the signals are right-sided, so corresponding to this pole the ROC will be outside. Okay, and corresponding to pole 2 again the ROC will be outside. Okay, like this. So what is the intersection? Intersection is still this final one, mod z greater than 2. This portion is the intersection. Okay, so this is the answer to the first part. The second question is x of n is equal to minus n into 1 by 3 raised to n u of minus n minus 1. For this we know that z transform of 1 by 3 to the power n u of n, we know it's pretty simple, z by z minus 1 by 3, and ROC is mod z greater than 1 by 3. Okay, and I can write ROC is mod z greater than 1 by 3. Let me there. Okay, now what is the z transform of minus 1 by 3 to the power n u of minus n minus 1? What is the z transform? I will say the z transform will be the same value, z by z minus 1 by 3, right? Because this is a right-sided signal and this is the mere left-sided version of this signal. So these two signals share the same z transform, but what is the only difference? The only difference is in the ROC. For this thing, left-sided signal, ROC will be mod z less than 1 by 3. Okay, this is the only difference. Now look at the given question. Here, for this part, minus 1 by 3 raised to n u of n minus 1, we can write z transform of minus 1 by 3 to the power n u of minus n minus 1 will be z by z minus 1 by 3, as you have got here, and ROC is mod z less than 1 by 3. Okay, now what is the z transform of n into, we are multiplying this with n inside the z transform, so minus n into 1 by 3 raised to n u of minus n minus 1 equal to, what will be the value? Again we have to find use an equation, I mean the property, differentiation in frequency property of z transform. What is it? Differentiation in frequency. Differentiation in frequency property. It says that if x of n has a z transform x of z, then n into x of n will be having a z transform. What will be that? Minus z into d by dz of x of z. Okay, so let's make use of this property. What you will get is, so from comparing these two expressions, these two time domains, we are multiplying this value with n. Okay, so the z transform will be equal to minus z into d by dz of Z transform of this thing, that is Z by Z minus 1 by 3. Now it's only a matter of simplifying. Minus Z into Z minus 1 by 3 into 1 minus Z into 1 divided by Z minus 1 by 3 square. Okay, so this will be equal to minus Z into, this is Z minus 1 by 3 minus Z, so minus 1 by 3 by Z minus 1 by 3 square, that is equal to plus, will be plus Z by 3 divided by Z minus 1 by 3 square. So this is the ROC of the question, Z transform of the question, and ROC is, we have already found it, it is mod Z less than 1 by 3. So we have done all the questions from this textbook, and thank you for listening.